Okay, I'm back. This is part 2. Alright, so now we move on to number 7. Don't let the numbering freak you out too much, because see how it goes from 7 to 13 to 9. I got this review from somewhere, so just, again, that's an 8. Don't let that freak you out. It's okay. It's just a problem. Alright, so I'm going to put a star by these. Let me scroll down. Oh, I'm sorry. I got to do this like that so I can write on it. Sorry about that. Okay, so here, I wanted to put a star by these because, again, this should be an 8. Because this right here is fair game, but it comes from the ones we just said up above, 4, 5, and 6. So I'm going to go through these very carefully, and this is something you may see on the test. Okay, because we did see it in the practice quiz and all that good stuff, and it'll just give you some more explanation. Alright, so the first thing your brain should be thinking about is, I'm talking about classifying systems. If it's inconsistent, that means I have no solution. So what does that mean? You can scroll back up or go play back the last few minutes of the video. If it has no solution, that means that we are parallel to each other. We do not intersect, so therefore that means my M1 is equal to my M2. Okay, my M1 and M2, so we're parallel, but that our B1s and B2, our Y-intercepts are not equal. So the way to do this is, let's change them both into Y-intercept. So for this top one, we got 3y is equal to negative 2x plus 6. Okay, and then for this guy right here, I have 4y. I know I didn't finish yet. Well, let me finish the top line. Divide by 3 to everybody, so let's just put y is equal to negative 2/3 x. I'm dividing by 3 to every term, plus 2. Alright, now I'll go to the next one, and I have 4y equal negative 3nx. And then I have this plus 12p here. Divide by 4 to everything, or every term. So y is equal to negative 3/4 nx. And then 12 divided by 4 is 3p. Okay, so now that we have these two lines, I'm going to look at them a little carefully. And basically what it's saying is that, hey, our slopes should be equal or equivalent to each other. So that means I'm going to take this number right here, because that is the coefficient in front of my x variable. Then I'm also, again, going to take the coefficient and that n, and I'm going to set these two equal to each other, and I'm going to ignore the x value because, again, that's the information that has to do with our slopes. I hope that makes sense to you. Okay, so again, I'm saying we're going to take negative 2/3, set it equal to negative 3/4 n, and again, we're looking for the n value that makes this an inconsistent system. Alright, so I'm going to multiply this side by negative 4/3, the reciprocal, to both sides. Okay, and so again, this stuff will cancel out. Again, this is positive 12 divided by 12, which is 1, so I got n isolated by itself. And this is positive 8/9, and that's the answer. Okay, so 8/9 is the value for n that would make my slopes be parallel to each other. As far as the p-value, okay, remember, we can have different y-intercepts. So in this case, let's see, we could take, all I have is this. Okay, alright, I just had a little bit of thinking to do here. Alright, so again, because our B1 and our B2 cannot be equal to each other, what we're going to do now is we're going to look right here. Oh, I gotta choose the... We have to look at our y-intercepts, which are our B values, and we're going to set these two equal to each other, alright? So we're going to just put 12 is equal to 3. Well, I guess I could put... What did I do? Oh, I'm using the wrong thing. Hold on. Back up. I get it. This is coming from the same line. I'm sorry. It's because I'm used to them stacked on top of each other. So we're actually going to take this value here, and we're going to do 2 is equal to 3p. Alright? And then we're just going to divide by 3 to solve for the p value. Now in this case, when p is equal to 2/3, meaning that if I take the 2/3 and I plug it into here, see, that's going to give me a 2 in this area here. And I don't want my B1 and B2 to be equal to each other, because if I do that, that would mean that they are infinite solutions, the same line. So basically we want P not to equal. So that's why on this one, P cannot equal 2/3, because I do not want my B1 and B2 to be equal to each other. I want them not to be equal. So P can be absolutely anything, just not this value. And when you write that, P cannot equal this, you're telling me P can be anything but that. That takes care of that one. All right. So I'm going to kind of erase now, just to make some space. So again, N was equal to 8/9. And then here, P could not equal 2/3. Okay, sorry for the noise, guys. Hopefully you can still hear me. I'm also realizing that having my sweater, it's scratching against the microphone. So I'm going to pull my sleeves up. It's cold in here. And that will stop that scratching noise. So I apologize for that. Okay, so now let's go to number 8. So if we say we are consistent and independent, that means we only have one solution. And if we have one solution, that means that, guess what? Our M1 and M2 do not equal one another. They can be anything. They will intersect. And also that our B1 and our B2, that doesn't even matter. The whole point is that our slopes are not the same. So we're going to take it and go to slope intercept. So I'm going to move this way. So I'm going to have y is equal to 3x minus 15. For the bottom one, we're going to have 7y is equal to, but I'm going to move this over. So this becomes nx plus 14p, like that. Okay, so we're just going to focus on these two numbers. Uh-oh, I got to divide by 7. I got that. To each one. So this becomes y is equal to, let me erase this little line. So now I have y is equal to 1/7 n 7. I'm sorry, 1/7 nx, and then plus 2p. And I'm going to just restack this one right under there so I can see it. Okay, so now we're going to focus on these numbers here. Again, we don't want them to be equal to each other. So if I do 1/7 n equals to 3, I'm looking for the value that I don't want, because I don't want them to equal each other. I want them to be different. So multiply by 7, multiply by 7. Okay, so one thing that I noticed in this particular problem is that when you look at the answer key, and again, this is someone else's solutions that I grabbed this. They gave me this review and these solutions, but again, I want to give explanations. But I believe this one is not correct, because it says on the answer key, n cannot equal 3. But again, they did not divide by their 7. So be careful with that. That's why I had to go back and I made that one little error with the divide by 7 to each term. So what I'm saying is you want that n could not equal, let me click my little pen, n cannot equal 21. So the answer is not n cannot equal 3, because again, in the answer key, if you look at it, they didn't divide by 7. You just want to say n cannot equal 21. Because when n is equal to 21, and you plug that in right here, right, you would basically get 21 divided by 7, and see that equals 3. And so when 3x is equal to 3x, or our slopes are the same, that would mean that we have parallel lines. And in this case, we have intersecting lines, and we want one solution. All right, so again, the answer should have been n cannot equal 21. Hope that makes sense. We don't care about the y-intercepts. So the answer to this one more time, I'm just going to write it right here, cannot equal 21. And then I'm going to erase. All right, so those were your solutions. Number 7, again, n equals 8/9, p cannot equal 2/3, and this one, n cannot equal 21. And I'm going to erase this. All right, so let's go to the next one, number 9. All right, so when you say that systems are consistent and dependent, then that means that you are saying you have infinite solutions. Infinite solutions. So that means that your M1 is equal to M2, and your B1 is equal to B2. They are the same line. I'll write that up at the top. So for this one, again, let's change back into y-intercept. So for this one, I'm going to have -8. Y is equal to -6x plus 24. Divide by 8 everywhere, or excuse me, divide by -8 to each one of these terms, and get y is equal to, divide by -8, divide by -8. Okay, so this becomes a positive 3/4. x, and this becomes a 3. Okay. Then on this bottom one, I have negative 4y, and then I'm going to subtract this guy over. So negative 8nx, and then I have this positive 1/3 p. Divide by negative 4, divide by negative 4, and again, do not let this math right here mess you up, and I'll do the scratch work. So now we have y is equal to, this is a positive 2 nx, and for this math here, if you have a fraction being divided by negative 4 over 1, change division into multiplication, and then flip, do the reciprocal. So negative 1/4. Okay, these little small arithmetic things in math, and it does matter. You have to just stay fresh on those kind of skills, okay? So this becomes a negative 1 over 12. So negative 1/12, okay, is the piece that's back there. All right, so now, again, I'm used to stacking them on top of each other so I can get a good look at them. Plus a 3 right here for the y-intercept for that one. All right, so again, we want our m's to be the same, and we want our b's to be the same. Try to make sure I didn't, oh yeah, wait, I feel like I'm missing, oh, I forgot to put the p-value. Where are you? You were on this guy right there. Be careful. The other one doesn't have a p. Yeah, the second one has a p. So again, this one came from the bottom one. The one below came from the top. And it's getting a little messy here, and I'm getting tired. Here we go. So we want to take these, set it equal, because we're looking for the n value that makes those two equal. So we got 2n equals 3/4. You can ignore the x value. So right here we're going to divide by 2, which is the same as multiplying by 1/2. So n is equal to 3/8. So we want n to equal to 3/8 so that our slopes will be the same. So I'm going to put that right here on the side. N equals 3/8. And be neater than me. I would also box these answers. Just saying. Box the answers. Okay. All right, so I'm going to erase because it got a little crazy. Now let's go focus on our slope intercepts. Okay, so I'm going to erase. And I want my y-intercepts to be equal, so I got rid of that. So now we're going to take this stuff here and set that equal. So negative 1/12 p is equal to 3. I'm looking for the p-value that makes those be equivalent. Okay, so I'm going to multiply by the reciprocal, which is a negative 12 over 1. Okay, so then of course negative 12 times negative 1 is a positive 12 over 12 is equal to 1. So p is equal to, and this is over 1, so this is just negative 36. All right, so when my p is equal to negative 36 and when my n is equal to 3/8, that's when I'll get a consistent and dependent system. Okay, hopefully that makes sense now, and you should be very comfortable with classifying. Just replay the video for whatever you need. Okay, so I'm going to clear this off for a second. Where is that at? I don't know. I'm just going to close this. I'm going to move down, and let's talk about substitution and elimination. All right. All right, here we go. So these are, you know, if anything, if I was on a student level, I would feel really comfortable with substitution and elimination and understanding, hey, I can take one of the equations, put it in terms of x and y, plug it into the other one, and that would give me or spit out one of my variables, and then, right? So substitution, elimination, don't let this freak you out. I'm going to move very quick. I would be more concerned if I was going through the lab. The stuff that had to do with the consistent, inconsistent classifying, maybe that trips me up, you know? But graphing lines is not that bad. And then again, we will talk about inequalities and shading. That shouldn't be that bad, all right? So again, that's just me, but I'm just saying there's some things to stress over and there's some stuff not to stress too bad over, all right? So let's talk about substitution. In my mind, this guy is the one that I would just, hey, I want to get x by itself because I have a 1x right here. So I'm going to just say x is equal to 3y plus 1. Pretty easy, okay? I'm going to take another color. And when I say substitution, I'm saying if x equals, I like to put the word is, x is the same as 3y plus 1. So if x is equal to 3y plus 1, that means in this second equation, I should be able to substitute and for that x, a 3y plus 1, set it equal to 12y plus 4, and then guess what? Everything is in terms of y. I can solve for y. So now I'm going to do the distributive property and get 12y plus 4 is equal to 12y plus 4, and this is hilarious because now if I subtract 12y, like I'm solving for y, I'm going to subtract this 4 over. I'm doing 2 steps at the same time. Nobody freak out. So now I have 0 equals, and in this case, 0. And is that a true statement? Yes, that's true. 0 equals 0, so therefore I told you guys infinite solutions. Done. Okay, so this one is infinite solutions, which means if somebody asked you just to check if it was about classifying, this would be consistent and dependent. Somebody asked you. All right, so let's go to the next one. This one I noticed there's a lone y, so I'm going to manipulate this top one and get y is equal to, and I'm going to do negative 6x minus 6. Change colors. So again, I like the word is. Equal means is, so y is the same as negative 6x minus 6. So let's take all of this expression, because that's y, and we're plugging that in. Substitute right there. So now when I rewrite this equation, 3, open parentheses, here's the substitution, equals 17, and then do the distributive property. So I have 4x minus 18x minus 18 plus 17. Hopefully, yep, that looks good. Alright, now of course we're going to combine like terms, and this is going to be negative 14x, and then one step, add the 18 over to this side. So that's going to be what? 35 divided by negative 14 divided by negative 14. So I got, I'm going to go this way, x is equal to, and then I would just take my calculator real quick and just do the math and figure out, can 14 go in there evenly, which I don't think that it will, because I know 14 times 2 is 28, so 14 times 3, I think that's 42, so it doesn't. So let's just leave it as a fraction. Yeah, let's just leave it as a fraction. So negative 35 over 14. Just leave that like it is. Okay, but now we're not done, because again, we want to find out the solution, right? We're solving. So you have to plug this value back in. So let's take this. I'm going to use another color. It's going to look a little weird. I'm going to take this value, which is x, and I'm going to plug it back into here to get y. So I'm going to say y is equal to negative 6, but I'm going to put it over 1, and I'm multiplying because my x value is negative 35 over 14, and then again I got this minus 6 in the back. So watch my math here, okay? So you could just, again, what if they say no calculator? So you got to be able to deal with the arithmetic. So I'm going to reduce diagonally. I'm going to divide this guy by 2. That changes to a 3. I'm going to divide this guy by 2. That becomes a 7. Okay. So now what I'm working with here is I can't reduce anymore, so now I have to face the fact that I have a negative times a negative is a positive, and on the side of my paper, 35 times 3, 9, 10, 105. So right here in the numerator, I have y is equal to 105 over 7. Okay? Now, I still need to subtract away the 6. So when I subtract away the 6, and I'm going to just do that real quick. Well, that's just going to be like 6 over 1. But I need a 7, so times 7 times 7. Okay, so that becomes a 42 over 7. Then I'm going to take this 105. Again, I know my final answer has to be y equal a 7 on the bottom, because again, when you subtract fractions, they have to have the same common denominator. So I'm going to subtract 42 away from this 105. 0, this becomes a 10. And that becomes 63 when I do my subtraction. So now I have 63 over 7, and there's 9. All right, so the final answer, again, scratch work matters, use a piece of paper. The final answer to this problem, I'm going to write it right here by number 11, is it's negative 35 over 14, comma, 9. And I will box this, and I have all my work shown. All right, so again, I didn't use a calculator, all right? And that's not to say you won't have one. I'm just saying get comfortable with the real foundational math stuff, all right? All right, so now let me, I'm not going to have enough room, so I'm going to close this out real quick. This video, I got 5 more minutes. Let's go to these two. All right, so now let's talk about elimination. Now I'm going to see if I gotta have to do another screenshot. Sorry about this. Okay, so for these two, elimination means something cancels out. So again, you want your x's stacked on each other and your y's. Now, again, be clever. When I look at this, I'm telling myself, hey, I'm going to get rid of x. That's just me. But you could get rid of y. And let me say this very slowly. So in this case, you're already a -3, and I'm already a positive number. And we both can be multiples, because guess what? 12 is a multiple of 3. So I'm going to take this top one, and I'm going to multiply by 4. Because again, I want a -12x. So now I'm going to do the distributive property to every term, even back here to the constant. And then I'm going to rewrite this right below. So this becomes -12x plus 4y. And then I get equal to a 4. Okay? And now I want to add these two equations together. And guess what? My x's cancel out. And guess who else cancels out? My y's. So now I have 0 is equal to, we're doing -3 plus 4, which is 1. And this is a false statement. So because we get a false statement, we say we have, because they don't equal, no solution. That's where all this stuff comes into play with our critical thinking, okay? Don't forget that true and false stuff. All right, so now I'm going to come over to number 13. And now this one, see, it doesn't really work with me, but you still can manipulate them. Please listen to what I'm saying. So it's up to you. If you want to get rid of x, always do getting rid of x. If you want to do y, get rid of y. So I'm going to show you 2 ways to do this. I already know that 2 and 5, the multiple is 10. But again, one has to be negative and one has to be positive. So what I'm going to do is I'm going to multiply the top one just by a 5. Okay, the bottom one I need to multiply, because I'm getting rid of x, by a -2. Because I'm trying to achieve in the front that, hey, you give me a 10x. Okay, and again, you have to do the distributive property to each term. So we're going to get a 15y. And then on the side of my paper, 17 times 5. 5, 6, 7, 8. This is an 85. There you go. Okay. Now I'm going to come back to the bottom one and multiply a -2 by each term and get a -10x. That's what I want. And then I do -2 times 8 for -16y. And then I know this is -40. And I'm adding them together. All right, so my x terms are gone. And I'm doing 15 plus -16, which is a -y. And then I'm doing 85 minus 40, which should just be 45 positive. Right? So this is 45. So I get y is equal to -45. That takes care of y. Okay, and now that I have y is, or y equals -45, it does not matter, and I'm just going to do some erasing real quick. It doesn't matter if I plug it into the top or the bottom one, so I'm going to get rid of all this stuff here. Again, you know where I got it from. It doesn't matter if you use the original top one or the bottom one. Okay, and in my case, I'm just going to use the top one. Alright, so again, I'm looking for x. I got 2x, but where the y is, I'm plugging in -45 equals 17. And now I'm going to say 2x, and I'm going to do some scratch work here. I got -45 times 3. That's 15. Carry the 1. That's 12, 13. So I got -135 here. Hopefully my math is good. Add 135 to both sides. And I got 2x is equal to, and then again, I'm going to just tell myself for the sake of this, hey, you're positive and I want to add 17. You can keep doing your scratch work. 12, carry the 1, 3, 4, 5, 152. And then I would come back and just half in that, right? So I would say 152 divided by 2 goes in there 7 times for 14. I already noted the 7. And then there's 1, bring down, so 76. Yep, and I got it right. Okay, so here's my y value, there's my x value, and the final answer is 76, comma, -45. Big numbers, but trust yourself. And again, you can check. So you can plug in 76 into here. You can plug in -45 into there. Do your arithmetic. It should equal out to 17. All right, so I'm going to stop this video here. Every video I'm trying to do less than 25 minutes, all right? So this was part 2. Again, what I went over was substitution, elimination, and the questions that were up at the top of page 2. All right, I'm getting ready to start part 3.